Hi, welcome back to Null Miko channel. You have an idea, an event app where companies run booths, customers play games, collect stamps, and get a reward after 4 stamps. You could start coding right away, or you could do what more and more teams are doing. Write the spec first, then let AI build from it. That's spec-driven development. In this video, we'll cover what it is, how it's different from the old way of building software, and walk through exactly how you'd use it to build that stamp and reward product from zero. Let's go. Spec-driven development means before you write code, you write a specification. That spec is the contract for how your product should behave. It becomes the single source of truth. Your AI coding tools, Copilot, Claude, Cursor, whatever you use, then generate, test, and validate code against that spec. You're not vibe coding and hoping the output is right. You're steering with a clear target. So the flow is specify first, then plan technically, then break into tasks, then implement. The spec drives everything. If something doesn't make sense, you go back to the spec. When the product grows, you refine the spec. When a task feels too big, you break it down in the spec and plan. That's the core idea, a bit of history. The idea of spec first, nailing down requirements before you write code, has been around for a long time. Books in the 50s and 60s talked about it. NASA's Mercury project in the 60s used test-first practices. Those ideas evolved into test-driven development and agile. In the 2000s, researchers looked at combining specification-driven approaches with agile and TDD. What's different now is that with AI writing code, the spec isn't just a static document. It becomes an artifact that drives the AI to produce code. So spec-driven development has come back into the spotlight. In August 2025, GitHub open sourced it, and in September they announced Spec Kit, a toolkit built for AI coding agents that formalizes this into 4 phases: specify, plan, tasks, implement. Spec Kit is MIT licensed, widely used, and actively maintained. If you want to do SDD in VS Code with Copilot or Cursor, you can use it. Next, how it differs from the traditional way. In the traditional software development lifecycle, you usually have phases: requirements, design, implementation, testing, deployment. Often it's document heavy and linear. You write a big requirements doc, then a design doc, then code. Problems? Documents go stale. What gets built drifts from what was written. And when you use an AI to just build a feature, the AI has to guess a lot. So you get code that looks right but doesn't match your real intent, or doesn't fit your stack, or misses edge cases. Spec-driven development flips the script in a few ways. First, the spec is the source of truth, not a one-time document. It's meant to be living. You update it as you learn. The AI uses it every time it generates or changes code. Second, you separate what from how. The spec captures what the product should do and what success looks like for users. The technical plan captures how you'll build it: stack, architecture, constraints. That way you can change technology or refactor without rewriting the whole product vision. Third, the workflow is built for AI. You don't hand the AI a vague prompt like add stamp collection. You hand it a clear spec, a technical plan, and concrete tasks. So the AI knows what to build, how to build it, and in what order. Less guesswork, fewer surprises. Fourth, you validate at each step. After the spec, you check: does this really describe what we want? After the plan, you check: does this match our stack and constraints? After tasks, you check: can we implement and test each one? So you're not reviewing a 1,000-line dump of code, you're reviewing focused chunks that map to the spec. So traditional SDLC often leaves docs behind and hopes they stay in sync. SDD makes the spec the driver. Traditional SDLC plus AI often means vague prompts and wrong assumptions. SDD gives the AI a clear contract so it can generate code that actually matches your intent. Tools like GitHub's Spec Kit formalize this into 4 phases. Phase 1, specify. You give a high-level description of what you're building and why. Not use React and PostgreSQL, that comes later. You focus on who will use this, what problem does it solve, how do they interact with it, what does success look like. The AI expands that into a detailed specification: user journeys, experiences, outcomes. This spec is a living artifact. You can refine it as you learn. Phase 2, plan. Now you get technical. You provide your stack, architecture, and constraints: company standards, legacy systems, compliance, performance goals. The AI produces a technical plan. You can ask for multiple plan options and compare. If you have internal docs or ADRs, you can feed those in so the plan follows your real architecture. Phase 3, tasks. The AI takes the spec and the plan and breaks them into small reviewable tasks. Each task should be something you can implement and test on its own. So instead of build authentication, you get things like create a user registration endpoint that validates email format, or add a stamp collection API that checks the user has completed the booth game. That gives the AI a clear checklist and you a way to validate progress. Phase 4, implement. Your coding agent tackles the tasks one by one, or in parallel where it makes sense. You review focused changes that map to specific tasks. The AI knows what to build from the spec, how to build it from the plan, and what to do next from the task list. At each phase, you have a checkpoint. Reflect, refine, and only then move on. The AI generates, you verify. Let's make this concrete. Say you want to build a product like Collect and Reward, companies register and use it for event planning. They set up booths. At each booth, customers play a game. When they finish, they get a stamp. After collecting 4 stamps, they can claim a reward. You've never built it before. How does SDD play out? Step 1, specify. You might say, we need a platform for event organizers. Companies register and create events. Each event has multiple booths. At each booth, staff can mark that a customer completed the game and award a digital stamp. Customers see their stamps on a phone or card. When they have 4 stamps, they can redeem a reward. We need to support multiple events and multiple companies. You don't mention databases or APIs yet. The AI turns this into a structured spec. Actors, company admins, booth staff, customers, user flows, register company, create event, add booths, check in customers, award stamps, redeem reward, and success criteria, e.g. customer can see stamp count and redeem once they have 4. You review and adjust until it really matches what you want. Step 2, plan. You say, we want a web app, backend Node or Python, REST API, front-end React or similar, database, PostgreSQL. We need multi-tenancy. Each company has its own events and data. We need simple auth for company admins and booth staff, and a way for customers to identify themselves, e.g. QR code or code. The AI produces a technical plan, data model, companies, events, booth, stamps, rewards, redemptions, API design, auth strategy, and how stamp collection and reward logic work. You might add, we need to support offline or bad network at the booth. The plan gets updated. You approve the plan before any code. Step 3, tasks. The AI breaks the spec and plan into tasks. For example, 1, set up project and database schema for companies and events. 2, implement company registration and login. 3, implement event and booth CRUD for company admins. 4, implement award stamp flow for booth staff. Validate game completion, record stamp. 5, implement customer view. Show my stamps for this event. 6, implement reward redemption when stamp count reaches 4. 7, add basic reporting for organizers. Each task is small enough to implement and test in isolation. You might reorder or split, then you lock the task list. Step 4, implement. You point your coding agent at task 1. It generates the schema and migrations. You review, run tests, then move to task 2. Same for each task. The agent has the spec, so it knows the business rules, e.g. 4 stamps, then reward. It has the plan, so it uses your stack and patterns. It has the task, so it doesn't overbuild or underbuild. You're not debugging a giant blob of code. You're reviewing one task at a time and checking it against the spec. So for collect and reward from 0, specify the event, booth, stamp, reward experience, plan the multi-tenant web app and APIs, break into tasks, then implement task by task with your AI. The workflow keeps intent and implementation aligned. AI is great at pattern completion, but not at reading your mind. A vague prompt like add stamp collection forces it to guess requirements, edge cases, and priorities. A clear spec plus a technical plan plus concrete tasks removes most of that guesswork. The AI knows what to build, how to build it, and in what order. That's why this works across stacks and team sizes. For bigger teams, the spec and plan are also the place to put security, compliance, and design rules. So the AI doesn't invent them, it follows them. Now let's do it for real, so you know exactly how. I'll share my screen and use Visual Studio Code with the official GitHub Spec Kit. The link is in the description. First, install the Spec Kit CLI. Open a terminal. If you have Python and UV, run UV tool install specify cli -- from git plus https://github.com/github/speckit.git. Then create the project, specify init collect and reward -- AI Copilot if you use VS Code with Copilot, or -- AI cursor agent if you use Cursor. That creates a folder called collect and reward with Spec Kit structure, .specify, scripts, templates. Go into that folder and open it in VS Code with code. Or open the folder from the editor. Open the AI chat, Copilot chat in VS Code or Cursor Composer. You'll see SpecKit /commands, speckit.constitution, speckit.specify, speckit.plan, speckit.tasks, and speckit.implement. Step 1. Optionally run /speckit.constitution to set project principles. Then describe what you're building. For example, collect and reward, event organizers, companies create events and booths, staff award a stamp when a customer completes the game, customers get a code and redeem when they have 4 stamps. Run /speckit.specify and paste that description. The agent generates the spec, actors, user flows, success criteria, and saves it under .specify specs. You review and refine, then move on. Step 2. Give your technical direction. Node and Express backend, SQLite, static HTML, and JavaScript frontend, REST API for companies, events, booths, join, stamps, and redeem. Run /speckit.plan and paste that. The agent produces the technical plan, data model, API, stamp, and reward logic in the feature folder. You review and approve. Step 3, run /speckit.tasks. The agent reads the spec and plan and outputs a task list, schema, company registration, event, and booth CRUD, award stamp, customer stamp view, reward redemption. Each task is implementable and testable on its own. You can reorder or split, then lock the list. Step 4, run /speckit.implement. The agent runs through the tasks and builds the feature, database, API, and UI. You review the code, run the app, and test in the browser. So in practice, one project, one spec, one plan, one task list, and your AI assistant in VS Code doing the implementation step by step using the real SpecKit commands. The full step-by-step and copy-paste prompts are in the description. Look for the demo guide. That's how you do spec-driven development with real tools. So spec-driven development means spec first, then plan, then tasks, then implementation. It's different from traditional SDLC because the spec is the living driver and the process is designed for AI. We walked through the concept, the collect and reward example, and the exact workflow in VS Code with the official spec kit. Install CLI, specify init collect and reward, then /speckit.specify, plan, tasks, and implement. The description has a link to GitHub Spec Kit and to the demo guide with copy-paste prompts. Thanks for watching. Like and subscribe to the Null Miko channel if this was useful, and tell me in the comments what you'd build with SDD first.